A little bit of a draft physics video, I think, draft science. Anyway, so I did post a video of the story, the complete story on Vlogger Dome. So if you haven't seen that, yeah, I think it's a pretty good rundown, an hour's worth of just explaining it from beginning to end, sort of. And I wasn't displeased with it, but you know, it's not very popular. But we'll see. Keep doing what I'm doing. You know, I'm going to fix some segments. So anyway, I do have a thought on the first segment. I just kind of negated accounting for, because I really can't account for it in any like definitive way yet. Is the idea of of the whole shadow concept is sort of dependent on the idea that when gravity goes through something, it somehow is changed, and changed like magnetism. Magnetism works on certain things, and then things that aren't magnetic are completely oblivious to the magnetism. It's the same kind of an effect. There's something, when the gravity goes through the Earth, it's changed. So the idea, the principle is that yes, there's this idea that there's this constant pressure coming in, you know, from all directions. And what is implied or implicit in the conservation of conservation of gravitons, you could say, is that this stuff has to go out. And so the argument I would make is that the stuff is going out in a new direction. You know, whatever goes in comes out in some other direction. Probably, I don't know, I like this 90-degree idea that that's what most of these interactions are. You know, and that stuff will come out. So what goes in comes out. And so if what goes in came out, the idea would be is that the gravity going in the side of the Earth, let's say, would come out the front of the Earth, which would mean it would be pushing me back up. So, you know, there would be an equal balance of what goes in and what comes out, so that from any one direction you couldn't really technically block anything, because technically it comes out the side. It has to go somewhere. So that there would still be gravity and equal pressure going out as that went in. But the idea is this polarization thing. So the idea that the stuff comes out different. So the magnetosphere, for example, you know, the magnetic poles of the Earth, all of that's created by gravity. So that force obviously comes out in a special way, a way magnetism comes out in this polarized way. And the same kind of effect, I would argue, is happening when gravity goes through something. It's polarized. And depending on how it's polarized would effectively change its transparency or visibility. So I've speculated before that polarization would be, you know, something like this shape change. So something has a directionality to it. And the thing I didn't account for is that there's a right side and a left side, really. So these directions are all the directions there are. These are just inverses of this one would go over here, this one would go down here, and so there would be the same, identical for top to bottom. And I'm speculating that, you know, that electricity would be somewhere in here, magnetism would be, you know, this polarization group. And what I haven't accounted for is the fact that this one over here, things going on this side, would be perhaps, or what's coming out of gravity when it goes in and comes out again. So it's coming out in a form that is invisible to everything. It has the wrong polarization to affect the way most matter is built. And maybe it can affect matter that has opposite spins, or maybe it can affect atoms that have opposite spins, or some kind of thing, but it doesn't affect common matter, or any matter we know of. We haven't, I don't think, found anything that's not gravitationally affected. I see some superconductors can behave in a way that seems gravitationally oblivious, but that's because it's in a strong magnetic influence. But that might be a giveaway that there are materials that actually are, but they're going to be affected by some other force, so the effect of the other force is going to make it difficult to detect whether there's a force of gravity. But anyway, not terribly pertinent, I don't think. So the point would be is that what comes in, say if there's two bodies next to each other and they're doing this force creation, is the idea that the force that comes in and comes out again is polarized. And even if it was just a regular polarization, you could argue that if more of it's coming this way than in all ways, that it's less likely to have the same effect, because it's just going to hit one part of the matter. So it's only going to be influencing some smaller percentage of all the impacts that would be possible on its path through something. It's going to have less likelihood of hitting more stuff if they're all the same polarization. So there's going to be more misses that way. So that would also account for the weakness of the counter gravity, the expelled gravity. And so that's why the expelled gravity obviously is weaker, because we're pulled to the earth. So the stuff coming out somehow is weaker stuff. Weaker in the sense that it's not as reactive. We're not as sensitive to it. And that lack of sensitivity means we get pushed down. We have more interactions take place from the force coming down than we have interactions from the force going up. It's something that needs to be explained, but I don't think it's a critical problem, because, like I said, magnetism already demonstrates this idea that there's a force that only certain matter in certain configurations will be receptive to, you could argue. So like things like iron and metals, certain metals that will be influenced by this magnetic force, where tissue paper won't be. So just thought I'd throw that in. That's one thing that's sort of missing from the description. I mean, I got into polarization. I just didn't get into the fact that there must be more of it than we realize. And certainly gravity polarization, no one's talked about at all. So it's a completely open area for conversation, in the sense that gravity is creating magnetism, and is also a feature in the migration of electricity. I don't quite know how to describe electricity, so I'm not quite sure whether it's a movement of electrons or a transmission between electrons. They're just transmitting the gravity between them, and we consider that because it gets transmitted to an endpoint where the electrons actually do the moving, but it's still a migration, not necessarily a movement of electrons, but a migration of the disposition of a vibration, a wave. So a wave of higher directional potential, something like that. But anyway, I don't want to get into that in this video. But yeah, I think it's all there, pretty much. So I'll read a couple of comments. There weren't much to work with, unfortunately. I mean, I wish I was getting more detailed analysis, something that was more critical or whatever, more to some point or to some experiment that makes this all quite impossible or something. And I suppose I'm going to have to do some analysis of the math, because I'm Einstein's convergence, the idea of the bent space, it's completely consistent with this theory, in the sense that instead of its space being bent, it's this idea of these directional arrows and their polarization. And the only thing that's really changed is his conclusions regarding gravity and light, and that light is being bent by gravity rather than light being bent by the symptom of gravity, which is a confluence of substance around everything. All matter would be leaching particles, that it ends up sucking back in again through magnetic and static electrical forces, and that's creating the lensing. And the time dilation is also not because space is bent, it's because velocity does change the atomic metabolism, and that velocity is always higher in stronger gravitational fields because of this idea of the bouncing. You're releasing, you're being pulled off your trajectory more frequently. You're bouncing a lot, creating a lot more distance to be traveled, which means your actual atoms are traveling a lot more distance in the same amount of time, quote unquote, and therefore must have an increased velocity. And it's the velocity that's creating the time dilation by slowing down the metabolism. The routine of the atom is slowed down by its necessity that it spend some portion of its time moving, which is totally intuitive and sensible as an explanation. Alright, anyway. Starting at 46 minutes, there's a problem with the audio balance, sometimes suddenly changing between the speakers. Yes, well, that's just because I sped up the last two sections a little bit, 10%. And I don't really hear it on my computer, so, maybe you have better audio equipment than I have, and maybe there is some artifact. Maybe you could record the artifact and somehow make it understood to me that it's somehow a problem because I can't hear it. But regardless, it doesn't matter substantially, I don't think. It's a physics video. Point taken. And then, it's why I didn't include the old fan. It made a little photon joke, but it was a little bit vulgar, so I also didn't include it because it's a little bit too funny for this video. I refreshed and replayed earlier parts of the video and played other videos, and it seems to be a problem with the part of the video rather than my computer. Well, I'm conceding it's probably just because I did speed it up, which means it screws with the audio to keep the pitch the same of my voice. See, I can speed it up without changing the pitch of the voice so I don't turn into a chipmunk. And I guess it does that by probably changing it from stereo to mono, or I don't know. Maybe, I don't know. Anyway. Crown Jewels guy, hey, how are you? I haven't seen him for a long time. Anyway, hello. Very much intuitive understanding. That makes a lot of sense. Hope to see more physics video. I have a question where you were saying at 11 minutes that GPS satellites have faster clocks than on Earth. Yeah, well, that was the joke, right? Is everybody thought, by the theory of relativity, that that it would the intuitive responses by the theory of relativity is that the satellites are moving faster because they have this overt velocity that seems very fast from our perspective. But it's, again, you have to do this perspective of the individual pieces that are being gravitational influenced. So they're moving much faster than the velocity of the whole thing. So when the whole thing has a certain velocity, it means the internal parts have a much faster velocity because they're doing a lot of moving around while they're moving in a direction. And it's that whole leasing thing. So the satellites are pulled down out of their normal trajectory. They're pulled down, which creates all this extra distance. They keep doing this extra curving thing to create the round orbit. So if it's going, say, 10,000 miles an hour, the parts inside are probably going 30,000. So, and the expectation is that obviously something in space moving really fast has to be going faster than us because we're just going the speed of the surface of the Earth. And that's where the mistake was made in the intuitive sense, in the sense that they didn't realize that we're actually moving faster. And so relativity takes care of that because, Einstein applies gravity to velocity. So there's a sensible connection between the fact that you're being accelerated even when you don't think you're being accelerated. So I'm in gravity, and although I'm not moving down from perception, I am actually moving down. So I am being accelerated 16 feet a second materially. My matter is. But it's also being pushed back up 16 feet a second in the opposite direction. So I'm being herky-jerkied. So just like the satellite being released, I'm being released even though I don't feel it, even though I don't sense it. It's what's happening. I'm really moving that away, and the Earth keeps pushing, the gravity keeps pushing me down, and it's pushing me down much faster, much more often, because I'm in a heavier, stronger gravity. So my frequency is much faster up and down than those satellites. So even though the satellite's going faster than I am, I'm doing this more often. So I'm actually going faster than the satellite. So my clock is actually slower than the satellite. And that's how the facts turned out. It turns out that GPS satellites are running too fast, not too slow. And it's because the Earth clocks are bouncing a whole lot, and they're moving much slower because of all that extra distance. I explained it in the video, but I know it's a little unintuitive, but yes, it's an actual fact that the GPS satellites' clocks are moving faster than the Earth clocks. Or just the difference between the clocks in orbit running slower. Well, they're actually running faster. And on Earth is lessened because our bouncing velocity. Clarification, I think I clarified it, I don't know. Or just the difference between clocks in orbit and on Earth is lesser because of our bouncing velocity. Well, you didn't say that very well, but I assume you're saying that our speed is lesser because of the bouncing velocity. Anyway, so I think I've clarified it. But thank you very much. I did receive a big pile of crap from some asshole today. It's just amazing. Like a book worth of type, you know, printed. How did I put it? Just insulting me, which I thought was really amazing. That somebody would send, you know, I don't know, it's like 50 pages of, you know, small print, which I really find annoying. I mean, small for my old eyes. Yeah, just ragging on me. It's just amazing. I don't know, so there's, but there appears to be some physics in there, and he just, you know, just rags on my lack of qualifications to have opinions, and like I don't know anything, and blah blah blah, and it really is insulting and pointless. But I mean, I just make a specific argument. Maybe he makes one somewhere in there, I'll look for it, but so far I haven't had to find specific arguments. And then he mentions Building 7, you know, conspiracy theory, crazy. Fire couldn't tear the building down. You know, just amazing. The building right next to it, both of them, 200-story buildings, fell to the ground, annihilated all structure, vibrated the fuck out of that building, and you're surprised it fell down. You're surprised the building next to 200-story buildings that fell down. That it might be structurally weakened, and then it was on fire to boot, and had been hit by rubble. And this, I'm supposed to explain why it fell down. I mean, it's like, you know, on the Richter scale, 100 feet from where the two big buildings fell down had to be, you know, a magnitude 7 or 8 earthquake. I mean, it has to be somewhere around there, one would assume. 100 feet? Yeah. 200 feet? Yeah. Anyway, till next time. I mean, it's a fucking island. It's a fucking cruddy, sandy, cruddy little soil and shit. You know. It doesn't take much to knock a building down. Wait till they have the big one in New York. You know. Anyway. Well, don't wait, because it's not going to be a good day. Oy. California's way overdue, you know. I mean, they haven't had a real big one in an important place in quite a while. Yeesh. Anyway, I remember the last big one. Anyway, till next time.